Hey everyone, I'm Darshan Senthil and welcome to this practice problems video. I promised I'd make this one in my previous video on logarithms. So here I'm just going to go over 7 examples with all these types of problems, and all of these problems are just basically where we apply the properties we got in the previous video. That's all we're going to do. We're just going to keep applying those properties again and again and again. And hopefully by the time you're done with this video, you'd have got a pretty good gist of how we use these properties, because these properties are not problems that will be directly tested on more for the most part, but rather they're stuff that can just help you make logarithms a lot easier. So hopefully you can use that to your advantage. And this video is a pretty free-flowing video, so you can do a lot of stuff with it. You can watch all my examples and watch how I do it step by step, so that I'm doing all these problems step by step, all 7. So you can see the various steps and see how I do it. So hopefully you can learn that way, or you can do what I prefer to do and just pause the video before I do a problem, and then do the problem yourself on a separate sheet of paper or something, and then just resume the video and see if you got the right answer. And if you didn't get the right answer, watch the explanation to see why you got the wrong answer, because I'm going over it step by step and highlighting a lot of things that you need to know along the way. So either way, I hope this video proves to be an educational video for you, and you really you learn something. So let's go. So for this first problem, it's not a very hard one, as you can see. You probably got the answer already. So we've got log base 4 of 4 to the 2/3 power. And if you remember, our property states that, first I'm going to write the problem down here so we have an extra copy to work with. Log base 4 of 4 to the 2/3. If you remember our properties say that if we've got the power for our logarithm, we can just simply bring it to the front of our logarithm. So that's what I'm going to do. So if we read out this, it would be 2/3 of log base 4 of 4. And what is log base 4 of 4? That is basically 1, because 4 to the first power is equal to 4. So that would wait, no need for the log. That would be just 1 times 2/3, which would be 2/3. That's your answer. That's it. So you might have got this answer a lot quicker than I did, and if you did, that's great, because these problems are not very difficult ones. They're just ones that require you to use these concepts. So if you understood this, then wonderful. But if you probably did not see this first up and it took a little bit of time, then I hope you understood it now. So yep, that's it for this problem. Let's move on to the next one. So this is log base 3 of 1/3. Now immediately this may look a little bit, you may be a little bit confused, but you just need to look, whenever you look at a problem, just look and see how can I apply my properties here. Now since we've got a fraction here, if you recall, we're just going to need to use our division property, and that would be subtraction. So what we're going to do here is we're going to rewrite this, because I don't like working with fractions, because it's a little bit confusing. So I just like to split it up into 2 different logarithms that have whole numbers in them, because we like logarithms that have whole numbers. So I'm just going to do that so that we can solve them a lot easier. So this is just going to be rewritten as using our subtraction property. That would be log base 3 of 1 minus log base 3 of 3. So 3 to the what power is 1. Now first up, that might be a bit confusing, but actually if you recall, if you just know your exponent properties, you'll know that anything like x to the 0 power is always going to be 1. You can have any number here from like -6 to like 60 trillion. Anything to the 0 power is always going to be equal to 1. So the answer to this is simply going to be 0. And minus 3 to the what power is 3. That's gonna be 1. If you wanted to rewrite this, you could say 3 to the x power is 3, and this would be 1. You could write it this way as well. So 0 minus 1, which would be -1. And it's also kind of handy to know that whenever you've got a negative power, like if you've got 5, for example, to the negative, let's say, x, then the answer to this would be to just flip it, to take the inverse of it, and then the denominator would have that power. So this was 5 times negative 2, 5 to the negative 2 power. This would be 1 over 5 to 5 squared, which would be 1 over 25. So just keep that in mind. This is pretty useful even when you're not doing logarithms, but when you're solving, say, exponential equations, this is pretty helpful to know. Okay, so next problem. Now log base, now you may see there's no base over here, but if you remember from my previous video, I said that whenever you've got nothing over here as your base, you automatically need to assume that that's going to be log base 10. Because it's really commonly used, so people just decide to leave out the 10, so they don't necessarily write that again and again. So it's when you're doing your work and stuff, if you want to use log base 10, it's good. But when you're writing final answers on your answer sheet, then you should just write log. Don't add the base 10. It's just good math etiquette. Okay, so once again, I don't like working with radicals and whole numbers in the same place. I like to split them up, because if you work with them at the same time, you're going to get confused. So what we're going to do is we're going to split this up using our addition property, and that would simply be log base 10 of 10 plus, since it's multiplication, log base square root of 10. Before we go any further, it's kind of hard to look at a logarithm with a radical, because I don't seem to have addressed any property that deals with radicals directly. So what we're going to do is, on the side, we're just going to simply pull this and rewrite it in a way that's more easy for us to solve. So log base radical root 10. If you remember from what I said in my previous video, whenever you've got a square root, or a radical for that matter, you can rewrite it as a fraction power. So in this case, we've got a square root. So the square root of x would be x to the 1/2 power. Similarly, if you've got a cube root, it would be x to the 1/3 power. And you would keep going on. So in this case, since we've got the square root of 10, we can simply rewrite this as log base 10 to the 1/2 power. And have I taught you something that deals with radicals? Exponents in your logarithm? Yes, I have. So we can use this to solve that then. So now we're going to plug this back into our original one, and now we're going to start solving for these two. So log base 10 of 10 is simply 10 to the what power is equal to 1 is to 10, and x is going to be equal to 1 there. So this is basically going to be 1, and then we get our plus sign, and then we're going to write this as log base 10 to the 1/2, and we're just going to bring this thing in front. So half log of 10, we already did that here, and that's 1. So this is just going to be half of 1, which is equal to half. So 1 plus 1/2 is equal to 3 halves, or 1.5. You can write it either way. This would be your final answer to this. So I hope you see what I did. I just split it up into two separate logarithms, and I converted the radical to a power, and then I solved it using my properties. So again, I hope you see how I'm just using the properties to simplify rather than fully solve. I'm just making this into stuff that is much easier for me to solve quickly. And this is going to be a crucial skill when you're doing a lot of stuff later. Like, yeah, that's it. So that's it for this example. Let's move on to number 4. And we're nearly halfway done. We're more than halfway done with this video already. So this again looks a little bit, it's a fraction again. So as you know, I don't like working with fractions, so I want to split this up into two things that I can work with a lot easier. So I'm just going to do the same thing as I did last time. I'm going to use my subtraction property, and I'm going to make this log base 4 of 1 minus log base 4 of 64. Now, I don't know log base 4 of 64 on the top of my head. It's kind of a big number, 64. So I'm just going to split this up into stuff that I already know. So what two things can I multiply to get 64 and to get 64 that are divisible by 4? Just for easiness' sake, and that's actually going to be two numbers that multiply to equal 64 are actually 16 and 4. So I could write this as log base 4 of 16 plus, because we're multiplying, log base 4 of 4. And if you multiply it, 16 times 4 is 64. So then you could simplify these two and you would get 4 squared is 16. So you just rewrite that if you want. 4 to the x power is equal to 16, and this is 2. And this one again, 4 to the x power is equal to 4, and that's 1. Add, and that's 3. Now if you did this one directly, you also get the answer is 3. So now let's go back and finish the problem. So for this one, again, 4 to anything that gives you 1 is just going to be 0. So if you've got a logarithm of anything, if you've got 1 in any logarithm, the answer is just going to be 0. So that's 0 minus what we got here, 3, and your answer will be -3. So that's it. So I hope you see how I did that. I split it up again, and I split this one up into even smaller ones. So this takes a bit of time, but if you're really unsure about what this is, this can help you do that. Okay, so on to the next problem. Log of 28. So now this seems pretty simple, but actually what's happening here is we have been given some values here. We have been given these certain values. So we've been given log of 4 is equal to 0.602, and log of 7 is equal to about 0.845. So, okay, so what we're going to need to do now is we're going to need to use these values given here, and we're going to need to use them to solve this logarithm. So what it's testing us on here is not our skill to evaluate, but rather it's testing us on our skill to, use our properties to, to set up a logarithm that has, to set up two logarithms that use our given values here. So we're going to need to use our properties to get to something that we can use these for. Okay, so let's start solving this. So log of 28, and notice the base is just 10, and the base doesn't matter here since we're just working with these numbers. So 28 is actually, if you know your math, it's 7 times 4. So what we're going to do is we're first going to start by setting it up, and you will see why this is so important later. So we're just going to start by setting up the equation using logarithms. So if you remember, our multiplication property is basically that we need to add them. So log base 4 plus log base 7. And now, since we've got them into simplest terms possible, now we're going to plug in our values. So 0.602 plus 0.845. And if you added that, you would get the answer as roughly 1.447. It's not a perfect fraction or anything, but yeah, this is an acceptable answer for this type of problem. So that would be your final answer. So what we're going to do now is I'm just going to explain to you why you have to set it up like this first. Because if you don't set it up like this, you might be tempted to say, oh, log of 28, that's log of 7 times log of 4. And no, that's not right, because if we use our properties, it's supposed to be plus, not multiplied. So that's why you need to set it up and then substitute in and solve. Don't try to do too many things at once or you're gonna mess it up. So you can just see over here how it's useful to just sort of plug in your values and get that done. Okay, so next problem. Again, we've got to say we're using the same values here, and again we're gonna set up the equation before we solve, and for the same reason, because you might do something wrong, like log of 7 divided by log of 4, because this is actually not right, because here we're subtracting. That's why you want to set up your equation using your properties before you plug in values and solve. So that's what we're going to do now. We're going to do log of 7 minus log of 4, and we're just going to plug in values. 0.6, oh whoopsies, it's the other one. 0.845 minus 0.602, and that should give us 0.243. So again, just look at this and see that it's important to set it up using your properties before you plug in numbers. Just makes things a lot easier for you to look at. So if you'd done this, if you'd just gone too fast and done this, you'd have got a wrong answer. So just pay attention and always use your properties, because your properties won't lead you in the wrong way in the majority of the cases. So set up the things using your properties and then solve them. Don't try to do too many things at once. That's why. Because here, if you look at it, it's actually very tempting to just say sort of distribute the logarithm to both 7 and 4 and then sort of solve it. So just beware of that. Be careful. Oh, whoops, sorry, wrong problem. So to the final problem now. So in this problem, if this is probably the hardest problem of them all, it's the same values, of course. We're using the same logarithmic values here. But the problem is we don't have 4 and 7 presented to us in the open. Like, we can't really see 4 and 7 in here. But we're not going to panic. So we're going to start by just writing it out as we usually would in our subtraction property, because it's division. We're just going to start by writing it out. And yep, we're just going to start by writing this out here. And now, do you see 7 and 4 here in this thing anywhere? Well, if you actually look, this is just the same thing as log base, and 49 is 7 squared. So you can rewrite this as log of 7 squared minus, and 4, if you recall from one of our previous problems, 4 cubed is 64. So basically we could rewrite this as, one second. So we could rewrite this as log of 4 cubed. So now I hope you see what we've done. We've just simplified this into an exponential number. So we brought this down to numbers that we want here, and now we're going to solve this. And once again, we're just going to bring our exponents to the front. So this would just be 2 times log of 7 minus 3 times log of 4. And I hope you see why I pulled the exponent over up here first, because if I had left it here, then you might have been confused. You might have done once you've plugged the numbers in, you might have taken that number to the 3rd power, and that's not what we want. We want to multiply by it. That's why you want to simplify this completely and use all your properties before you plug in the numbers. Okay, so that's a lot of places you might slip, so just pay attention and be careful to that. Use all your properties and then plug in your values. So if we plug it in, we get 2 times 0.845 minus 3 times 0.602. 0.602. And if you solve that, you would get negative 0.116. If you just did all the calculations, that would be your final answer. So yep, that brings us to the end of this video. That's the 7 examples I promised. I hope you found it helpful. So I went and highlighted all this kind of stuff. So make sure you use your properties before you plug in numbers and stuff like that. So yeah, that's the big part of this video. You just need to make sure you understand how to apply these properties and how they can be helpful in making equations so much easier to solve. Okay, so yep, that's the end. Please do subscribe to my channel so when I post new videos you can get notifications, and also just so that you can keep up with my irregular posts, because I'm not a very regular poster. Like, I post when I feel like it, most likely, because I go to school as well, so I don't have all the time in the world. And yeah, so yep, that brings us to the end of this video. So thank you for watching, and yep, I'll see you next time.